Hello, math nerds. I think this is number 4 of the derivative series. Woohoo! And so number 4 is talking about the derivative of exponential and logarithmic functions. We're going to start off with some real just e to the x and natural log and talk about them and how to work that into what we've already done. And then in a few days, we're going to talk about a little bit more complicated exponential and log functions, but we don't need to get too complicated right now. So I'm just going to let you in on a secret, and this is really cool, that the derivative of e to the x is e to the x. I know, right? He is his own derivative. He is the only function who at any x value, the y value is also the slope of the tangent line there. Think about that. That the slope of the tangent line, the derivative, is the same as the y value. And if you think about how fast e to the x grows, that kind of makes sense that it would get really big as x got really big. And the other derivative I want to share with you is the derivative of natural log, and that is 1 over x. So we're just going to work through a few problems and kind of talk about how these derivatives play into the derivatives that we've already talked about and some of the rules that we've already talked about. So in number 1, we have 2 times e to the x. Well, we said yesterday in part 3 that if you have a constant times your function, the derivative is just the constant times the derivative of the function. Well, he is his own derivative, so that's it, y'all. I know, right? Isn't that crazy? I know, it's so nutty. So the derivative of 2 e to the x is 2 e to the x. I know it's nutty. All right, notice in number 2, we have, and let's change our notation to f prime of x. There we go. We have a constant times natural log. So the answer to that derivative is the constant times the derivative of natural log, which I told you was 1 over x. And then the derivative of 3 e to the x is going to be 3 e to the x. So that is the answer. I know, can it be that simple? Tell me no. And then number 3 is going to get just a little tougher. So I'm going to rewrite this because I see a radical. And so I'm going to think of this, and I'm writing equals because I'm just rewriting it, as 9 natural log of x times x to the 1/3. Remember, it's power over root, power over root. And what is happening between these two functions? I'm going to write them like this so you can see a little better. They are being multiplied, and anytime we multiply two functions, we have to use the product rule. Dun, dun, dun. And remember, the product rule is not simply the derivative of one times the other. No, 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 no. Remember the pattern. Okay? So this is 1 and this is 2, right? So it's 1d2 plus 2d1. Or, if this is f of x, if you want to get real formal, because I know a lot of you like to have the symbols, and that's okay. If we're going to call this f of x and call this g of x, then our derivative is 1d2 plus 2d1. Okay? And that is the derivative of, that is the product rule. Okay? All right, so here we go. So g prime of x requires the product rule because two functions are being multiplied. Two functions of x. You know, when we were over here, this is a 7 and a function of x. That's a constant times the function. A constant times the function. That's different than here's a function of x times another function of x, okay? For those of you who get a little confused about that. So here we go. So 1 is, and I'm going to put this in parentheses, it helps me organize. So 1 is 9 natural log of x times the derivative of the second. Power rule says to bring the power down. If you subtract 3 over 3 from 1 over 3, you get negative 2 over 3. So 1d2 plus 2, write it down, write the second function down, that's all you do. And then d1 is going to be a constant times the derivative of natural log, which is 1 over x. And again, guys, we're going to probably do a little better job of cleaning this up later, but for now, we're just trying to learn some rules and get our feet wet, so we're good for now. Okay, here's some more, and we're only actually going to do 4 and 5, and the reason is because I see a trig function, and we have not talked about trig functions yet, so we'll have to come back and do that one a little later. Okay, so let's look at 4, and 4, these aren't being multiplied, they're being divided. I must use the the quotient rule. The answer to a division problem is a quotient rule, and that is low, D high, minus high, D low, over low squared. And for those of you who prefer the symbols, trying to do this for both learners, that would be low function, derivative of the top, minus top, derivative of the bottom, over the bottom squared. Because that is the pattern that is formed when you do quotients. Okay, so here we go. So f prime of x is equal to, go ahead. You know, I found that if I'll go ahead and put my quotient, my line indicating that I'm going to have a quotient as an answer or a fraction, whatever, I won't forget that low squared. A lot of people forget it, so that might be a good hinty for you. So when we do low or g of x, you just write down what's there. So I'm just going to write down square root of x times the derivative of the top, which is simply e to the x, minus low d high minus high d low. Let me come over here and think about this. That is really x to the 1/2, right? So the derivative of that is 1/2 x to the negative 1/2. Okay, 1/2 x to the negative 1/2. And then over the bottom squared. And y'all do know that if I squared that square root, it would end up just being x, right? And later on, we'll have to clean this up, but for right now, that'll be fine. Unless you might at least want to put x in the bottom. That'd be good. All right, so look at number 5. OMG, that's so crazy looking. Why did I say rewrite this first? Because, guys, you've got to always know those log and exponential relationships. And we know that the natural log is the inverse function of e to the x. So if you compose, that means put in the inverse function into the x of its inverse, yeah, then you just simply come out with x. And when I talk to my kids about this, it's natural log of e to the bob, no matter what bob is. Yeah, nope, is bob. Because the inverse, because they're inverses, they kind of undo each other. It's just like the square root of x squared. You know how they undo each other and you get x? They are inverse functions. The square root of x and y equals x squared are inverse functions. So they're like inverse operations. They undo each other when you put one inside the other. And so because of that, you end up with just the x. So if we did that for this guy, this is really y equals natural log of e to the bob is just bob. So really, it's asking this question just a crazy way. And so the derivative, dy dx, is simply 2x. Isn't that crazy? Nutty, nutty, nutty. I know it is. All right, so that's it for, I think that's it for e to the x and natural log. Oh, no, I lied. I didn't mean to lie. So here, let's do some more. We cannot do 8. Look at there. I see a trig function. We can't do that one, so we won't worry about that one today. But we can do number 7 very quickly. Now, number 7 requires us to know another log law, and that is if you have natural log of a to the r, that can be written as r natural log of a. And the reason we do that is because when you rewrite that like that, you end up with that, pull that 5 up front, you end up with a constant times a function you know the derivative of. So to find f prime is really easy. Now notice that this is not the derivative. I'm rewriting it so it's easier. I like easy. I want that, right? So now I'm going to take the derivative, and that is the constant times the derivative of this function, which is 1 over x. So knowing that log law will help you rewrite it so that taking the derivative is easier, just like on that last one. We're not going to do a because of the trig functions. We'll come back to that. And number 9 is kind of tricky because really number 9, I'm not going to do a quotient rule because it's not two functions of x divided by each other. Instead, I'm just going to be real smart about how I look at it. And this is really the same as 1/2 e to the x, right? That's really, like times 1/2 times e to the x, it's the same thing. So how do you take the derivative of that? Well, it's constant times the derivative of the function, which is just e to the x. That's pretty easy, isn't it? And so we don't want to do a quotient rule unless both functions have an x in them, okay? When they look like this, we want to think about it as just a 1/2 in front of that function. All right, I think that does it. Let me see. Oh, Lordy. I have some, but they all have trig functions in them, so we'll have to come back to those. All right. So on our recap, for this real quickly, the derivative of e to the x is e to the x. So the slope at any point x is the same as the y value. The slope of the tangent line at any x is the same as the y value. Only guy who does that. Coolest guy ever. Love him. The derivative of natural log is simply 1 over x. You know that. It's going to be coming in handy. You do need to know your log laws, and that was found in this one. So number 5, don't forget we need to know our log laws. That natural log of e to the Bob is Bob, and so if you can simplify it before taking the derivative, you want to do that. And also, if you have the natural log of x to a power, let's go ahead and rewrite that first, bring that power down front, makes that derivative real simple. And if you do not have a quotient of two functions of x, then please don't do the quotient rule and just think about it better, in a better form, so it's easier to take the derivative. All right, well, thank you so much for natural log and e to the x, and I'll check you next time. We're going to look at the trig derivative. So tune in next time for trig derivatives. Thanks. Bye, guys.